Hi class, in this video here we now want to talk about two new rules, something called the product rule and something called the quotient rule, and this is just going to be for methods for finding the derivatives of functions. And then at the end of the lecture we're going to talk about something called higher order derivatives, which if it helps to think about it will be like the derivative of a derivative. And then what will the derivative of a derivative of a derivative be? Alright, anyway, so in this lecture here's what we're going to look at. We're going to first look at how to find the derivative of a function using what's called the product rule. Then we'll look about how you find the derivative function using the quotient rule. And then we'll talk about finding the derivative of a trigonometric function. So if you remember, we've already done sine and cosine, right? So we saw that the derivative with respect to x of sine of x, that's cosine of x. And the derivative with respect to x of cosine of x is equal to minus sine of x. Well, then what we're going to look at, like in this lecture here, is like, well, what is the derivative of tangent of x? You know, what will that be? And then we'll do secant, cosecant, and cotangent. And then the last thing we'll do is we'll talk about about finding a higher order derivative, and we'll also work some application problems. Okay. So let's start with the product rule. So the product of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative of f times g is the first function times the derivative of the second plus the second function times the derivative of the first. Okay, so derivative with respect to x of f of x times g of x is equal to, well, so the way we'll work through it is, and this will make more sense when you see the first example. We'll leave the first function alone, multiply it by the derivative of the second function. Then we'll add to it, we'll leave the second function alone, multiply it by the derivative of the first. Sometimes you'll also see me do it this way, just this is just how I'm used to doing it. If you have f times g, this would be derivative of the first times the second function plus the first function times the derivative of the second. It's just the same thing. They're just rewritten a different way, okay? So I'm primarily going to use this one right here, okay? So let's do some product rules, and I'll write the product rule up here just so we have it, okay? So it's a function f of x times g of x. So the way I'm going to do this, it's the derivative of the first function times the second function plus the first function times the derivative of the second function. All right, so let's find the derivatives of the following. So here will be the first one. F of x is equal to 2x squared times sine of x. So look, here's how you know that you have something being multiplied. If you could just take the 2x squared and treat it as its separate part and the sine x a separate part, look, you have your f of x right here, so from the formula, and then the g is this sine of x. So then f prime of x, well, you're going to take the derivative of the first function. Well, derivative of 2x squared, bring the 2 down. 2 times 2 is 4. Derivative of 2x become, derivative of x squared is just x here, times g of x, so times sine of x. And then you're going to add to it, you're going to leave the first function alone, 2x squared, and then the derivative of sine, we know is cosine of x. And that's it. So let's try another one. Let's look at f of x is equal to e to the x times cosine of x. Well, look, notice how you have two things being multiplied here. You have e to the x times cosine of x. So you're going to treat the e to the x as the f and the cosine of x as the g. Okay, so what I encourage you to do is to just, pause the video. You only see me do one, and give it a shot. All right, so if you just want to, watch me now, if you didn't want to pause it. So the derivative here, f prime of x. Well, what is the derivative of e to the x? We know that's e to the x, so times cosine of x, plus you're going to leave the first part alone, e to the x, and the derivative of cosine is minus sine of x. So look, you can even factor this out if you wanted. You could factor out a 2x here, but you could write this as e to the x times cosine of x, in this case minus sine of x. All right, let's just do this last one real quick. Let's look at y is equal to 5x cubed e to the x. Well then dy dx, derivative of the first part, so treat this as 5 times x cubed and then times e to the x. So bring the 3 down, this becomes 15x squared times e to the x plus the first function, first part here, which would be 5x cubed, and then the derivative of e to the x we know is e to the x. And you can leave it just like that. All right, now let's talk about the product rule, and don't worry, we'll do some more examples in the coming slides, but just follow the formula. Follow the formula. Now we have the quotient rule. So the quotient f divided by g of two differentiable functions f of g is itself differentiable at all values of x for which the g of x, the denominator, does not equal 0. Moreover, the derivative of f divided by g is given by, now this is where the formula gets a little bit complicated, is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. Okay. So I'm going to write it a little bit differently, okay? Than what you see here. The first thing you're going to do is you're going to take the derivative of the top, derivative of the numerator, multiply it by the denominator. Then you're going to subtract away, you're going to leave the numerator alone, multiplied by the derivative of the denominator. And then all you have to do is just whatever the denominator is, just leave it alone and square it. And that's it. Okay, so I'm going to work a couple examples of this so you can see what's going on here. So I'm going to rewrite the quotient rule just so we have it, okay? So the derivative with respect to x of f of x divided by g of x is equal to, so it's the derivative of the numerator times the denominator, so f prime of x times g of x, minus the numerator, f of x, times the derivative of the denominator, g prime of x, all divided by g of x squared. So, look, here'll be the first one. So we want to find the derivatives. So find the derivative of the following. So here'll be the first one. Let's look at f of x is equal to x squared over x plus 1. So look, this is my f of x in the formula, and this is my g of x. So f prime of x, take the derivative of the numerator, which was 2x, times the denominator, which is x plus 1, minus, okay, the numerator, which is x squared, times the derivative of the denominator. Well, the derivative of x is just 1, and the derivative of 1 is 0, so this is just times 1. All over x plus 1 squared, because you just square the denominator. So look, you're going to have to clean this up, okay? So this is 2x squared plus 1 minus x squared all over x plus 1 squared. 2x squared minus x squared just gets me x squared plus 1 divided by x plus 1 squared. So it's always going to be important to clean this up, to simplify it after you follow the formula. All right, let's try this one. F of t is equal to 3t squared minus 1 divided by 2t plus 5. All right, so the derivative, f prime of t. Take the derivative of the numerator. Well, the derivative of 3t squared minus 1 is just 6t. Multiply by the denominator, 2t plus 5, minus, leave this alone up here, 3t squared minus 1 times the derivative of the denominator, which would just be 2, all over 2t plus 5 squared. All right, so you have to clean this up. Distribute, right? 6t times 2t gets me 12t squared plus 30t. And then don't forget the negative here. So minus 6t squared. And then minus becomes positive plus 2. All divided by 2t plus 5 squared. So then I'm just going to clean this up, right? So this just becomes 12t minus 6t becomes 6t squared plus 30t plus 2 all over 2t plus 5 squared. And you could factor out a 2 in the numerator, but I'm just gonna leave it like that. So again, just follow the formula. Just follow the formula and then simplify the resulting expression. Let's try this one. So we're going to find the derivatives of, let's see, f of x is equal to sine of x divided by e to the x. Well, look, f prime of x, derivative of the numerator, so derivative of sine is cosine of x, times the denominator, which would be e to the x, minus sine of x, times the derivative of the denominator, well, the derivative of the denominator is just e to the x, all over e to the x, and then squared. Well, look, factor out an e to the x. This is going to be, this is why you want to do that. Hopefully you can see what's going to happen here. Cosine of x minus sine of x. This is all over x, and then the 2, so this becomes e to the 2x. But then one e to the x is going to cancel, and you're just left with cosine of x minus sine of x all over e to the x. All right, let's do this last one, just so we make sure we have this down. Let's look at f of t is equal to cosine of t over t to the 4th. So what you're going to want to do here, again is just follow the formula, right? So f prime of t, derivative of the numerator, so this is minus sine of t, times the denominator, which is t to the 4th, minus cosine of t, times the derivative of t to the 4th, which would be 4t cubed, all over this would be t to the 4th squared. Well, look, you're going to factor out a t cubed, and this becomes t to the 8th, so that you'll be left with just t to the 5th in the denominator. So this ends up being minus t sine of t minus 4 cosine of t all over t to the 5th. And I encourage you to, factor on your own and just verify, and see how I did that. Okay. So it looks like we've got these two formulas, which is great. Now we're able to handle these rational derivatives of basically rational functions, or anything that includes transcendental functions with the division part. And then we've also talked about this product rule. All right. So again, it's just follow the formula. Follow the formula. Now let's talk about the derivatives of trigonometric functions. So I'm going to prove one of these to you. But let's just go through these here. The derivative with respect to x of tangent of x is just secant squared of x. The derivative of cotangent of x is equal to minus cosecant squared of x. Derivative of secant of x is equal to secant of x times tangent of x. And a little bit of a typo here, but this is the derivative with respect to x of cosecant of x is equal to minus cosecant of x times cotangent of x. Now look, the proof of this one is in your text. So let me do this proof on the next slide of this, so you can see how this is solved. All right, so I want to prove to you that the derivative with respect to x of cotangent of x, okay, I want to show you that it ends up being negative cosecant squared of x. All right, well, to do this, what you're going to do is you're going to rewrite cotangent of x, right? So let's remember our trig identities, right? Cotangent of x is cosine of x over sine of x. And then all you're going to do here is you're going to apply the quotient rule. All right, so derivative of the top, so the numerator, so of cosine, so that's minus sine of x, times sine of x, minus cosine of x. Derivative of sine here is cosine, so cosine of x, all over sine squared of x, because you square the denominator. Well, look, let me factor out a negative here. Watch what happens. So I'm going to factor out a -1, and then I get sine times sine gets me sine squared of x. Cosine cosine gets me plus cosine squared of x. Well, the reason I factored out the negative, well, we know the trig identity sine squared of x plus cosine of squared of x is equal to 1. Well, look, 1 over sine is cosecant of x, so I have this negative. So 1 over sine squared then is negative cosecant squared of x. And we got it. So what you're really going to have to do, all right, is especially as you work through your homeworks here, just have these formulas that I'm giving you, just have them handy so that when you see these derivatives, you can just take them. But especially like if you're going to plan to go into Calculus 2, you're really going to want to have these memorized here. All right, let's do some problems, okay? So let's find the derivatives of the following, okay? So he'll be the first one. Let's look at f of x is equal to e to the x times tangent of x. Well, look, you're going to have to apply the quotient rule here, right? Or excuse me, the product rule. Sorry, not the quotient rule, the product rule. All right, so it's the derivative of the first. So that's just e to the x times tangent of x. Plus the first function, e to the x. And then just look back. Derivative of tangent of x is just secant squared of x. Just like that. And if I have this, f of x is equal to 5 times secant of x. Well, constant multiple rule, so the 5 just stays. And the derivative of secant of x is just secant of x tangent of x. So again, look, all this really is just following the formulas, right? So if you have f of theta is equal to theta squared times cosecant of theta, well then f prime of theta, again, you're going to have to use the product rule. Derivative of theta squared is 2 theta times cosecant of theta plus theta squared. And then just look back. Well, then what's the derivative of cosecant? It's just minus cosecant of x times tangent of x. Cotangent of x, excuse me. So this is just minus cosecant of theta times cotangent of theta, which is just 2 theta cosecant of theta minus theta squared cosecant of theta cotangent of theta. So again, just straight up following the formulas here. All right, so now what we want to talk about is these higher order derivatives. So if you've taken a physics class, right, you can obtain a velocity function by differentiating a position function, okay? So you can then obtain the acceleration function by differentiating a velocity function. So really what you're doing is taking the derivative twice of the position function. So as I just said, another way of looking at this is you can obtain an acceleration function by differentiating a position function twice. So this is a higher order derivatives, when you take derivatives of a derivative. And I'll work an application of this in a little bit. But here's the notation. So the second derivative is an example of a higher order derivative. You can define derivatives of any positive integer order. For instance, the third derivative is the derivative of the second derivative. Okay. And so the following is just all the notation for the higher order derivatives here. So the ones I'm going to do here is I'm going to do examples of the, we know the first derivative, that's what we've been taking. And then I'm going to do examples of the second derivative and the third derivative. But what you can see here is this is all the alternative formats, okay? These two notations sequence here are the most popular one, okay? So f double prime of x signifies the second derivative, or this d squared means the second derivative of y, divided by dx squared means with respect to the x variable twice, and so on. All right. So let's find f prime, f double prime, and f triple prime for the following. I'll do one easy one and then one a little bit harder one. So let's look at this one. F of x is equal to 3x cubed plus 7x squared plus 5x plus 2. Okay, so the first derivative, right? F prime of x. We'll bring the 3 down. This just becomes 9x squared. Bring the 2 down, plus 14x plus 5. And the derivative of a constant there is just 0. Now the second derivative, f double prime of x. You're just differentiating this. So bring the 2 down. This becomes 18x plus 14, and then that constant goes away. And then the third derivative is this derivative of this, which is just 18. So higher order derivatives just take derivatives of the derivatives. All right, let's do this crazy one here. So we're going to find the first, second, and third derivatives for f of x is equal to x squared times sine of x. All right, so what you're going to need to do here to find the first derivative is the product rule. So it's 2x times sine of x plus x squared times cosine of x. Now for the second derivative, you need to do the product rule twice. Okay, so the product rule of just this first part here is for derivative of 2x is 2 times sine of x, and then plus 2x, and then derivative of sine is cosine of x. Now here, okay, now I got to do the product rule of this. So plus derivative of x squared is 2x times cosine of x. Now x squared, notice I'm going to leave a blank in here for a second, x squared, and the derivative of cosine, that's where that minus comes from, is minus sine of x. Well, now look, so I can combine the middle term here. So this is 2 sine of x plus 4x cosine of x minus x squared sine of x. All right, so now the third derivative. So you're going to have to differentiate this first. So the derivative of sine is cosine, so this is just 2 cosine of x. Now here's what's crazy. You're going to get the product rule twice. So here, derivative of 4x is 4 times cosine of x. And then plus 4x, and then the derivative of sine, or derivative of cosine here, gets me minus sine of x. Now this negative, keep the negative with it. Okay, that's really, really, really important. So then here, all right, this becomes minus 2x sine of x minus x squared, and then derivative of sine of x is cosine of x. So a lot going on here, right? Like terms here, 2 cosine of x, 4 cosine of x gets me 6 cosine of x. Minus 4x minus 2x sine of x gets me minus 6x sine of x. And then minus x squared cosine of x. All right, so we've got it. All right, let's do. Let's end the lecture now. Maybe with two application problems. Okay. So we talked about position, velocity, and acceleration functions here. So suppose the velocity of an object is this. V of t is equal to 36 minus t squared. And this is, t is between 0 and 6. So v is measured in meters per second, and t is in time of seconds. Find the velocity and the acceleration of an object when t is equal to 3. Okay. Well, look. The acceleration is just the derivative of the velocity function. Well, the derivative of the velocity function is just negative 2t here. So when t is 3, the velocity, just plug it into the velocity function, right? So this is 36 minus 9 gets me 27, and it's going in meters per second. And then the acceleration at 3, well, that's just minus 2t, so it's minus 2 times 3 is equal to minus 6 meters per second. Okay, so what can be said about the speed of an object when the velocity and accelerations have opposite signs? So, the velocity is positive, so it's still zooming, but its acceleration is decreasing. So what's going on here is the speed of the object is decreasing. When the acceleration is negative, but the velocity is positive, the speed of the object is decreasing. All right, let's end on this one here. Okay, so a population of 500 bacteria is introduced into a culture and grows in number according to this equation. Okay, so it's the population at t, and it looks like t is measured in hours, is equal to 500 times 1 plus 4t divided by 50 plus t squared. And what I want to do is I want to find the rate at which the population is growing when t is equal to 2. So what I'm asking you here is to find the rate, so the rate of change. Okay, so what is that, right? Well, that's the slope, okay? And the slope of this function then would be the derivative. So we need to find the derivative. Okay, you could distribute the 500, all right? But best recognize when the 500 goes into here, okay, it's going to be 500. So P of t is equal to 500. And then distributing again, right, you get plus, it's basically, 500 times 4 gets me 1,000 t divided by 50 plus t squared. So P prime of t. Well, the derivative of this constant goes away. So then you're just going to need to use the quotient rule. So it's the top, which is 1,000. The derivative of the top, derivative of the numerator, which is 1,000, divided by the denominator, which is 50 plus t squared, minus the numerator here, which is 1,000 t, times the derivative of the denominator down here, which would just be 2t, all over 50 plus t squared. Sorry about that. Well, then look, to help clean this up, each of these terms have 1,000 in it, so I'm just going to factor that out, right? So this is 1,000, and then I have 50 plus t squared minus 2t squared. All over 50 plus t squared squared. So look, this ends up just being 1,000 times 50 minus t squared all over 50 plus t squared squared. So then if you want to find how much it's changing when t is equal to 2, you're just going to plug it in. And I'll just save us some time. Like when you plug this in here, you end up getting 31.55. So you can verify that on your own. But what that means is that when t is equal to 2, right, the rate at which the population is growing is 31.55 bacteria per hour. So again, it's just straight up following the formula to find the derivative and then plugging it in. All right, class, so I know this was another lengthy video with a lot of examples, but again, just follow the formulas for finding the derivatives. Take your time. There's a lot of opportunities to make a little bit of an error, but stick with it. Oh, and for example, I did make an error here. Yeah, just looking back. 500 times 4 gets me 2,000. That's funny. So even your professor here can make a little mistake, but I caught it. Okay, so sorry about that. 2,000, not 1,000. Silly mistake. All right, everybody. Again, that's why I said to check your work here. All right. If you have any questions, let me know.